KEET TV presents Homework Hotline, the after-school show that fuses learning with fun. Watch local teachers bring the classroom on air and online. This is Homework Hotline.
Welcome to Homework Hotline. My name is Amy Taylor and I teach 8th grade math and integrated 1 and 2 at Sunnybray through Zoom at home currently.
My name is Pam Halstead and I taught science at Fortuna High School.
Welcome to the show. Today's show is going to be on exponents, and I'm going to let you know everything I know about exponents. It's more just because it's one of those math things that relates to science, even sociology, even statistics, but the problem is we learn all these skills or these tricks. It's not even a skill, a trick. We mix them all up and then it just ends up getting confusing. So that's why I thought I'll just break it down and show you why, because it's one of those things I see happen. So we will start by, I'll just ask you questions and then we can
Great, that sounds perfect.
So when we take, well, do you know what the thing that we just start with is called, when we're taking a number and we move it to the exponent, that number we start with that we're going to do things to. Do you know the name of that word?
The moving of the number
the thing that we start with.
I'm sorry. I do not.
Oh, that's weird. Why is it not doing color? We'll do that again.
Pen 1.
Pen 1. All right. So if we have 5, that's called our base number.
Base. Okay.
There's other words for base, but it's the base number we're going to go over and over again. And then we say we have like a 2, and that's going to be our exponent.
Right.
And then the whole thing with exponents is that it is literally just repeated, basically multiplication, or you can say repeated addition. Sorry, I was tripping. Repeated multiplication or division. Multiplication. All right, it's good enough. So that's the big idea. And if we know that exponents mean repeated multiplication, so we're doing 5 times 5 here, then if we can understand that, the problem is I'm going to show you a rule where we multiply the same base. We add the exponents. I'll show you that. But the reason what happens is when we switch to a power of a power, people start mixing it up. So that's why we are I'm going to show you some shortcuts, but show you why, because I don't want you to mix them up. There's probably a better way to do this, but that's okay. All right, so we're going to start with numbers like, we'll do 3. So 3 squared times 3 to the 4th. Do you want to guess what someone might do that might be wrong here? I don't know.
Okay, sure. So they could go, they'd go 3 times 3 and they'd write a 9.
Oh, there we go. Yep.
And then they'd go 4 plus 2, or they'd go 2 times 4,
yes.
And that's 8.
That is a very typical. But think about it. If we have 3 times 3, which is 9, and then we have 3 times 3 times 3 times 3, which is 9 times 9, which is 81. 9 times 81 is not 9 to the 8th. That is 9 times 9 times 9. I don't even know what that is.
That's crazy huge.
But that's why we want to think of it in terms of what we're doing and not just in terms of, just do this trick. Okay. So really what you're doing is you don't change the base, and then you just count those copies. And that is the thing that we want to think about.
I'm just looking for an eraser.
Yeah, it's working.
Okay, fine. Sounds good. Just checking. Sorry.
No.
All right.
No, it's all good if you do find one, though.
Okay.
So what we want to do is we want to keep the base the same, and then we want to count how many are there. There's 1, 2, 3, 4, 5, 6. So this means that we have 6 copies of 3 multiplied together. But if you keep that in your brain, that exponents just mean copies of a base multiplied together, we don't get 9 to the 8th. And that's why I like to teach, I don't like to teach adding, so I like to say that basically when multiplying same base, I always do this, add, in quotes, the exponents, because what people do, not only do I sometimes get 3 times 3 is 9, I get 3 plus 3 is 6. So I get all kinds of things, but the reason when you multiply the same base, you add the exponents, 2 plus 4 is 6. The reason I do it in quotes is I want kids to really think you're counting copies. So if I'm counting 1, 2, 3, 4, 5, 6, yes, I'm quote adding the exponents, but when we start doing tricks like add, subtract, all of a sudden we're doing 3 plus 3 is 6. Or we're mixing it up and saying 6 to the 8th. So that's the big idea is, yes, we have these tricks, but really we're just counting copies multiplied together. So what happens with that is if we do a power of a power. And that's where people get even more confused, and that's why I'll talk about it. So we'll go fast. Get a workout racing. Okay. Okay, so the next thing is called the power of a power. We'll do this color. Power of a power. And this is where people start mixing up. So, for example, I try to use smaller numbers so we can figure out the answer easily. 2 cubed, let's say to the 4th power. That's not too bad. Kind of big. So what do you think people say is the answer to this? We could just guess something.
All right, I'll guess. So they say the answer to that is 2 to the 12th power.
That would be correct. What's a different way?
Sorry, dang. Okay. They say it would be 2 to the 7th power.
Yeah, I try to do what error are. But I just told you to add the exponents.
Yeah.
Well, 3 plus 4 is 7.
Right.
All right, cool. We're good.
But when I see the comma there, I think multiply. When I see the comma. Is that my clue?
Yes, it could be comma.
Okay.
So, kind of, maybe a comma.
Parenthesis. I'm sorry. I meant a parenthesis. I didn't mean a comma.
That would be multiply. So yeah, I'm not even sure what happens. I think it's just you heard adding. I just told you adding. Why is this not adding?
Yeah.
So I have told you that it's copies multiplied together, right? So let's go with what my definition was. So my base is 2. It's still 2. But this exponent is telling me that my base is actually 2 cubed. So what I'm doing is I'm doing 2 cubed once, 2 cubed twice, 2 cubed 3 times, 2 cubed 4 times. So what's happening there is you're actually doing 4 copies of 2 to the 3rd power. And at that point, that's where we're, quote, adding. But really, you can take it a step further, and you have 3 copies of 2 multiplied together, 3 copies of 2 multiplied together, and the last one. We have 4 sets. This means 4 copies of 3 2s multiplied together. So what you come up with is you have 8 times 8 times 8 times 8. And so it's more just, sometimes I have my kind of silly thing where I say, when in doubt, write it out. But I just tell kids, you usually don't have that many problems. So if you are confused, if you really do write out the copies, you're not going to make the same mistake. And typically it's not even a 2, it's an x, so they're just writing x to the 7th. But writing out those copies really makes a difference, and then it solidifies it in your head. Now what I tell kids to do, so when you see the rule for this, it'll say 2 to the 3 times 4. And that bothers me because really you're doing 4 copies of 3 2s multiplied together. So I have kids write 4 times 3, which is 12 copies. 3, 6, 9, 12. Now because of the, one more thing, commutative property, which means you can write multiplication in any order. 3 times 4, commute, move. 4 times 3 is 12 is the same. That's why they write it that way. But my feeling is if you don't describe why you're doing something and you don't think about what's happening, it's 4 copies of 3 multiplied together, then you basically start to mix it up. So with that said, yeah, if there's not an eraser, I can make these thicker too. So the gist is, in general, try to write out copies, or at least try to think about it in terms of writing out copies so that you don't have to, I think they're all thicker now. so that you don't have to worry about making those mistakes, because it really is. When I used to give paper tests, back with our paper tests, on this, I would just have everyone mix it up, and it was such a bummer because they would it's like it's so close, like a 7, it's 12 copies, and a 2, it's not that, it's bigger, but not crazy bigger, but it's just mixing up all those different skills. So the next one I'll do, and then I'll do a couple problems as examples, and you can help me with it. But the last one we'll do is we'll do dividing. So we'll do dividing. So we'll do 7 to the 4th. We'll do over 7s. Actually, I don't want to do 4th because sometimes when you deal with 2s, you can subtract and divide and get the same thing, and that's not helpful for teaching. So we'll do 5 and 2 equals. So what do you guess students do with this? What would be an answer? I don't know.
Okay, so 7 divided by 7 is 1.
Yeah, I do get that, yes.
Okay, cool. And then 5 over 2, it almost reminds me of fractions. Do I subtract the 5 minus 2?
Yeah, either way, or whatever.
5 minus 2?
We can do 1 to the 3rd. We could do 1 to the 5 halves.
5 halves. Right.
Either way, if you have 7 5s, this is where you want to write it out. If you have 5 sevens multiplied together, and you divide it by 2 sevens, you're not going to have 1 left. You're going to have a lot left. So that's where it's like 7 times 7 is 49. So there's no way you see all this. I mean, 7s are big. Even 1 7's big. It's not 1.
Oh, no. Good. Good, great.
So what we want to do is we say that, well, 7 divided by 7 is 1. And 1 is the identity, which is 1 time. The identity means, like, when yourself is your identity. So 1 times 7 stays 7, stays its identity. So 1 is the multiplicative identity. And then what we have left is 7 times 7 times 7, which is 7 cubed. And so we are technically subtracting, but just how I say that when you're counting copies, this is canceling copies. So we are basically dividing out 7s and canceling out copies to get a bunch of 1s, which are the identity, and then we end up with 7 cubed. So that rule is, I'll do it up here. When dividing the same base, you subtract the exponents. And then this is where I like to do my quotes, because you are subtracting, but I don't like using, technically the whole definition of exponents is multiplication division. So using words like add, subtract don't seem like they fit that at all, but it is a shortcut. But basically you subtract the exponents. What you're really doing is canceling copies. And so that's where we want to be careful. We can still use these rules if we understand why we're saying those rules, which is we are taking 5 copies of 7 multiplied together, canceling 2 copies of 7 multiplied together, which gives us 3 copies of 7 multiplied together.
That seems very helpful. I mean, I get it way better when you do that to it. But
I usually, you just get this. So you're learning so it's like a little slide, and it's like, when you divide, subtract. And the kids are like, okay. They don't even know what they're subtracting.
Yeah, and they're like, oh, 7 over 7, I'm just going to keep the 7, and not knowing why they're keeping any 7 for any reason.
Or they want a 1. And so,
Right.
So there's 2 other, small things. They're not small, they're hard. But one is a 0 exponent and one is a negative exponent. And then we can start doing putting some problems together. But I figured give the basics first. So I'll ask you this. What do you think, anything to the 0, what do you think people say is the answer?
0.
Yeah. So I have a couple ways to deal with that. So you say 2 to the 0. I keep using smaller numbers because why not? So people think it's 0. Okay.
Yes.
Well, the issue with that is I just told you that everything's multiply, divide. So if you cancel everything multiplying and dividing, that identity is not 0, it's 1. So we're not in add, subtract land. Add, subtract land, cool, 0. But we said add exponents, subtract. So it really just gets very confusing. So I have a couple ways to show that. So if we have I'll have you start with it. 2 to the third.
Okay.
For real answers, if you can. I mean.
2 times 2 times 2, is
Yeah,
that? Okay.
yeah.
Oh, 2 times 2 times 8?
Yes.
Yes, I think.
2 squared.
4.
2 to the first power.
2.
Okay, so what am I doing to get from 8 to 4? What am I doing?
Multiplying by, well, dividing by 2.
Yeah. One less copy of 2 that I'm multiplying, right?
Uh-huh.
And then,
Same thing.
okay, and then do it again. What's 2 divided by 2?
1.
Yep. And look what's happening to my exponents. I go from 3 to 2 to 1, so then it's 2 to the
0.
So that's just what, there's multiple ways I'll show you, but that's the big idea. We don't actually have a 0 anywhere because we're in multiply divide, right? So that is basically how you can kind of prove it to yourself. The other way is that I told you about subtracting exponents or canceling, and I'm going to show you that way also. So if you have, let's say we can do 2 to the third over 2 to the third, all right?
Okay.
Well, we know anything divided by itself is what?
1.
1. We could even write out 2 times 2 times 2, which is 8, divided by, any way you get it, anything divided by itself is 1. Okay, well then we had another rule we talked about. So we said when you divide the same base, you subtract, right? So you're subtracting out the copies. Well, 3 minus 3 is 0. So if we remove 3 copies, we have 0 copies left. And if we have 0 copies left, we have a bunch of 1s. It all ties together. And the other like kind of logical thing I'll tell people is just watching. If you do it, it's kind of fun. If you just watch everything get canceled out. So my brain says, this, I kind of came up with this fairly recently actually, but I just kept trying to think of ways to how things cancel. So if you have 2 to the 4th over 2 to the 4th, and you write them all out, 2, right? You're not sure what's going to happen. You don't know that anything divided by itself is 1 until it's something like, oh, I know 2 divided by 2 is 1. I know that. I know 2 divided by 2 is 1. And you keep going. Well, if you have 0 copies of 2 left, what does that mean? That means I've canceled everything out. And what do I have everywhere? I have 1 times 1 times 1 times 1 divided by 1 times 1 times 1 times 1. So basically, you should see 1s everywhere. So your brain can say, when I have 0 copies left, I've canceled everything. What do I have a bunch of? 1. So then your brain just thinks 1. And you don't keep seeing that. You don't see any zeros here. Minus them asking you, anything you show, you're just going to have 1. So those are kind of my 3 ways of doing that.
Cool.
The last thing, well, not the last thing, but kind of there's 5 major things when dealing with exponent rules, and the last one is negative exponents. So I will show you that as well.
Okay.
And then we can kind of do some sample problems where we kind of mix it all together, because that's usually what homework is. They kind of give you some shortcuts or some really things you should memorize, but you might mix up, and then they just give you a bunch of problems. So it's nice to actually know how to do it.
Yes.
All right. So the last one is, what if you have, say, like, I keep using numbers. I can use letters later, or variables later after this. So what if you have, whoops, I started to write 3 squared over 3 to the 5th. So then, what happens? Well, let's see. So you can guess. We can guess.
Okay, let's do it. So are we going to like 3 times 3 on the top over 3 times 3 times? Okay, let's do that.
Yes. Anyway, we're going to prove it. We'll do our proof ways.
Okay,
again.
good.
3, 4. Yep. Then what?
All right. So then we can cancel out the 3s,
Yep.
the first 2 3s
Yep.
for both of them, turn them into 1s. And now we have basically 1 over 3 times 3 times 3.
Yes. And we can even write
3 to the
cubed.
third.
Sure.
Yeah.
Okay, well then we had this other rule, right? Here, I'll use a different color just because it's fun. So then we do 3 squared. We had this rule that if we divide the same base, we subtract the exponents, right? Well, what's 2 minus 5?
Negative 3.
Yep. So what we find out is 3 to the negative 3 equals 1 over 3 cubed. Well, what's happening there? What are we doing there? So we can do that same little breakdown we did, where we say, well, what's 3 cubed What's 3 squared? What's 3 to the first? And then we'll keep going till we get to that.
Okay.
Okay, here we go.
Do we leave out 0? Does that matter?
Oh, I did leave out 0. It does matter.
It does matter. Okay.
Thank you.
Just making sure. Okay.
I'm like, I want to get to, I usually actually do squared typically
Okay,
because it
that's all right.
doesn't take
It's
as
all right.
much time. I'm like,
okay.
okay,
Yes.
let's keep, we could fit
Okay.
it. It's kind of a bigger screen.
Okay.
Okay, there we go. So let's start. 3 cubed.
3 cubed. 3 times 3 is 9. 27.
Yep. 3 squared.
9.
Yep.
3.
3 to the first.
3.
And now we know 3 to the 0, so we can go one more. Yep. But we don't know anything else. So let's see. What are we doing at each stage? How do I get from 27 to 9?
Dividing by 3.
Yep. How do I get from 9 to 3?
Same.
Divide by 3. How do I get from 3 to 1?
Divide by 3.
Yep. So let's keep dividing by 3. What do we get? What's 1 divided by 3?
1 divided by 3. 1 divided by 1/3.
Yeah.
Okay.
Exactly. Yeah.
Oh, okay.
Like just like that. Yeah.
Sure. Okay. Good. And then 1/9.
And then we divide one more 3. Yep. You're
3.
taking a third and dividing into 3 pieces.
So
So
it's
now
3
you have
squared. So it's
1/9. Yep.
1/9.
And the last one.
1/27.
Yes. Divide by 3 again. Is. And a lot of times, this is good to see both ways. So 1/3 cubed is 1/3 times 3 times 3, which is 27. But sometimes the homework will say leave it in exponential form. So you'll go 1/3 cubed. Sometimes it says no negative exponents, so you'd write it this way. Sometimes it says no fractions, 3 to the negative 3. Sometimes it says simplified, and simplified means get all your numbers multiplied out. I want to know it's a 27. Typically, when they say exponential, they do big numbers like 3 to the 25th. They don't want to have you write out that.
Writing it all out, sure.
But that's the big idea with negative exponents is just the reciprocal, and I will just explain that a little touch more because that gets confusing in terms of reciprocal. But that's all you're really doing. So a negative exponent just literally means inverse. And it was created to have you do the inverse. But when you're in multiply divide land, inverses mean a specific thing. So if you just say you have 2 to the negative 1, right? Well, this literally means inverse. All right, so when we're adding, so when we say inverse, say like, what's the inverse of plus 2? What's the inverse of plus
1/2?
No,
Wait.
like, oh, sorry, additive inverse.
The additive?
If you're adding subtract, what's the opposite, we'll say, of just adding 2?
-2?
Yeah.
Subtracting 2.
Yeah, so the inverse is 0, right?
Okay, sure.
So if we had a -4, what's the inverse of that?
Add
Additive
4.
inverse. Yeah, so so 0 is the additive inverse. Additive identity. So that's when we're adding and subtracting, we get 0. Well, exponents aren't add, subtract land. They're in multiply, divide land. So what's going to happen is our inverse is not considered to be the opposite. Opposite gets overused. Opposite is actually for add, subtract. Opposite of 2 is -2. But the reason I use inverse for everything is it can basically cancel everything. The point of the inverse is to get the identity. So if you have, so reciprocal. So if you have, I say hi to Pam and she says hi back, she's reciprocating my gesture. If 2 divides 1, how does 1 reciprocate 2? 1 divides 2. So if that means inverse, and in multiply divide land, inverse means reciprocal, then the reciprocal of 2/1 is, what's the reciprocal?
1/2.
Yeah. And that's really, it looks like this scary thing, like 2 to the -1. It's telling you, do the reciprocal of 2/1. So what would be 2/3 to the -1?
Flipped over,
Yeah.
3 halves?
Yeah.
Okay.
And so really just understanding the basis of all of this stuff, which it seems like it's a lot of different stuff, but if you really understand you're counting copies multiplied together, that covers a lot. If it's above and below, you're canceling copies when you divide. If you know A -1 literally just means the reciprocal. That's all it means. It means the inverse. And then anything to the 0 is 1. You cover everything you could do in just any kind of problem. So since we're getting towards the end, I'll just do a...
There's a lot of terms too that I'm noticing that would be good for students to know, because you're using a lot of terms to refer to numbers, which we're probably not used to. So you're using things, you know what I'm saying? I mean, there's a lot, so people can get lost in terminology and get confused, I think.
Yeah, and also, okay, we'll do like an actual, like, I don't know, kind of problem.
All right,
okay,
cool.
We'll do 2x squared y, not crazy.
All right, sounds good.
We'll do 2 to the 3rd, and we'll do 2 to the 5th, x to the 4th, and y to the 2nd. It doesn't matter.
All right.
So we're going to simplify this with our rules. Do you want to try and tell me? You can tell me like how many extra 2's say are on the top or bottom.
Okay, so on the bottom, I see there's 2 extra 2's.
2 extra 2's. How did you know that?
I knew that because I took 3 and subtracted 5. So, but I was on the bottom. I mean, the difference is I took basically 5 and subtracted 3.
Yeah, because you had 5 2's multiplied out on the bottom, 3 on the top. You have 2 extra left.
Right.
What about your x's?
I have 2 extra on the bottom. The same reason that we gave for the 2.
Yeah, we have 4 x's all multiplied out,
and then
2 cancel out, 2
yes.
extra on the bottom.
Yes.
Uh-oh, what do I do with this?
Oh, geez. Okay, so I don't know. Oh, wait. Oh, okay. Oh, it's like -1. Wait, is it?
It's
So I flip it.
reciprocal, yeah.
I flip it. So there's a y on the top.
So you move all 3 to the denominator because it's the reciprocal.
Oh.
So now you have 5 on
5
the bottom.
on the bottom. Okay.
And then everything else cancels, right? So then my answer is 1 over 4x squared y to the 5th.
Okay.
So basically, if you wanted to show work for that, you could say, okay, 2 cubed cancels out, that's a 1. 2 cubed, there's 2 extras. X squared cancels out, I have 2 extra. And this negative means it's in the numerator. I need to do the reciprocal. Now it's positive, and then I count 1, 2, 3, 4, 5. And now I have my 1 on the top and my 4x squared y to the 5th on the bottom.
Cool.
There's so much more to do with this. I knew this would, it's just exciting.
Because we did scientific notation next time.
Next time, yeah, next time
we're
in
together.
graphing and real life and exponential graphing, but it's just, there's so much just to get to this to understand it.
Sure.
So anyway, hopefully if you're doing this, this is definitely integrated 1, 2. There's so much science, 8th grade math, high school, I mean calculus even. So I hope that helps you.
It does. Oh, it does. Oh, I think I just had an idea. The next time we come on together, we could do something like with chemistry and with scientific notation. Yeah, that'd be good because you could explain the whole math part of it. I could explain the chemical part. Nice. That was very cool, Amy. Very helpful for people that are trying to figure that out. I know, totally is a lot. But we're so happy that you guys have tuned in.
Thanks for tuning in.
Thank you. Bye-bye.